Hi everyone, you're welcome to Maths Experience. Right, my name is Precious. So in this video, we want to look at the concept of the cross product of vectors, which is also called the vector product. You recall in our last video, we talked about the dot product. Okay, and one thing must be understood here that the same condition for dot product, which is that it is only defined for two vectors of the same dimension, the same is applicable for the cross product. The cross product is defined, in fact, in particular, is defined for only three-dimensional vectors. So that is to say, for instance, you can see here I am saying that u is a vector, of dimension 3. It's coming from R3, and so you have u1, u2, u3, and the same applicable to v. Okay, so if there are two vectors, we say that their cross product is defined as another vector represented by this. That's u cross v. That is the representation for cross product. And this is the formula. Now, one thing should be noted that the dot product gives you or results into a scalar. When you take the dot product of u and v, you are going to get a scalar, and that's why it's also called a scalar product. But when you take the cross product of two vectors, you are going to get a vector, and that's why it's also called a vector product. Okay, so now when we define a vector product, this is what we get. So you can see this is a vector represented in the component form. The first component is also going to give you a three-dimensional vector. So the first component is u3 multiplying u2 multiplying v3 minus u3 multiplying v2. Okay, and then one thing you should note in this formula is that for each of the components, the very particular number is missing. So you can see here u1 and v1 is missing. Now in the component 2, you can see that u2 and v2 is missing. And then here you can see that u3 and v3 is missing. So that's also something that can give you an idea. However, I will always teach students not to go along cramming this formula or memorizing it, to use it in determining the cross product of any two given vectors, because there is actually a process that brought about this formula, and that is what I'm going to show you here now. So you can actually find the cross product of two vectors by taking the determinant, arranging them in a form of determinant where you recall determinant of matrices. So for instance, this is going to be like this. So you recall that this is your normal ijk for three-dimensional vectors. So you will begin with that. So we have ijk here, and then you draw your line here. So all you need to do is represent the components of your u and v, starting with u under this ijk. So the I component of u is u1, the j component is u2, and the k component is u3. So and then I take the second vector, which is v1. So you recall that, of course, we are going to see it that if you are asked to get u cross v, then the components of u must come first, like what we have here, and then the components of v will now follow. So, but if you are asked to get v cross u, you take the components of v first before the components of u. The reason is because, of course, we are going to see it as one of the properties of cross product. The cross product is not commutative. U cross V is not equal to V cross U. All right, please take note of that. So what do? You want to get the determinant. You will usually give signs to each of the columns. So the first column is starts with positive and then it alternates. So you have negative and then positive. So let's begin. So I'll start with positive I. So you know how to take your determinant. You will cross this and also cross this, and then you will now take your normal diagonal multiplication. This will multiply this, and then will multiply this one will multiply this, and you subtract. So I'm going to have u2 multiplying v3, then minus u3 multiplying v2. So you can already see where this formula is coming from. That's this one that I gave you here. Okay, so if you now go to j, you will have minus j, and in the bracket you will have okay, so recall that for j you are going to cancel the center and then the first one. So you have u1 multiplying v3 minus u3 multiplying v1. Okay, so finally we go to k. Of course, you will remove this and the column of k. So for k we are going to have, of course it's positive, so you have plus k into the bracket of okay, so you have u1 multiplying v2, and then that is minus, you will then have u2 multiplying v1. Okay, so this is going to give us I into u2 u3 minus u3 v2, and then you will now have plus. I am bringing the minus sign into the bracket, and when minus multiplies this, it will become negative. But if it multiplies this one will turn to positive. So I want to write that one first. So I'll have u3 v1, and then this first one that has become negative will now come later. So I'll now have u1 v3, and finally my k remains the same because it is positive. So I needed to make the second one positive so that I can represent this in component form. And so in my component form now, I am exactly now going to get what you have here. So you can already see it. The first component is u3v3 minus u3v2. Sorry, u2v3 minus u3v2, which is this first one. And then the second one is this positive, and then the third one is that. So that's actually how that formula was gotten. But like I said earlier, you don't need to do or to carry or memorize these formulas, or this formula while trying to get the vector product. All you need to do is draw up your matrix determinant line, and then represent the two vectors you are given, and that would help you get what you want. There is also another way of knowing, or determining or showing that the cross product of two vectors is equal to what we have given. Maybe I should call this equation 1, that is equal to equation 1. So that is a more elaborate proof for that. Okay, so I'm going to show that in a later video. Now let's take some examples. Now this example says that we are given that u is I minus 2j plus 3k, and v is equal to that, and we are asked to find these particular values. That's u cross v, v cross u, and all of that. So we begin with the first one. So our u cross v, like I said, and this is positive, negative, positive. So I am going to have the components of my ijk. So the component here is 1. My cross product is going to be, I'll begin with I, and that is going to give me minus 2 times minus 1, which is positive 2, minus my 3 times 1, which is 3. And then for j is going to be minus j, which is going to be, of course, 1 will multiply minus 1 because you cancel the middle row, the middle column and the first row. So that's going to give you negative 1 minus, of course, you will now do 3 multiplying 2, which will give you 6. Now the next, which is the k, is going to be positive k, and then you will now do, of course, this row, the last column will be cancelled, so you have 1 multiplying 1 and minus 2 multiplying 2. which will give us 1 minus, okay, of course, minus 2 times 2 is minus 4, so minus times minus will be plus 4. 2 minus 3 is minus 1, and so that will give us minus I. Minus 1 minus 6 is minus 7. Multiplying minus j will give us plus 7j. And then finally we will have plus 5k. So, and that's simply our cross product. And like we said, you already now have a vector as your solution for the example A, which is actually a cross product. And then the next one, which is the B, which is V cross U. So all you need to do this time is to bring in the components of V first. And from what we are going to do now, you will see that vector product is not commutative. So we start with I, and so I'm going to have 1 times 3 minus this. So this will be 3. Then this times this is positive 2. So I'm going to have minus 2. And then minus j into, of course, for j, the center will cancel. So this will multiply this and this will multiply this, which is 6. Minus 1 times 1 is minus 1. And then when you do minus minus, you have plus. All right. And then finally for k, so this and this will go. So we'll have plus k into 4 times, 2 times minus 2 is minus 4. Then minus 1 multiplying 1 is 1. So your solution is simply positive I, negative 7j, and then negative 5k. So this eventually shows us that the the direction of this is just what has changed. That your U cross V is actually equal to negative V cross U. Okay, they are in opposite direction, but of course their magnitude is the same. If you check the magnitude, you're going to get the same value. So if I take the dot product of U cross V together with U, what I'm going to have is my U cross V is this one. That's minus 1 comma 7. So if you open that bracket, you're going to have minus 1 times 1 is 1, then plus 7 times minus 2 is minus 14, then plus 5 times 3 is 15. So if you add all of this, you are going to get 0. Okay, so I'm going to allow you to do the second one. That's already D, and I will tell you that definitely you're going to also get 0. And this is actually pointing to something we are going to see under the properties of vector product, which tells us that U cross V is actually orthogonal to both U and V. And we're going to see a proof to this particular property when we go to that discussion. Okay, quickly, let's look at this other example. All you need to do here, like I said, is draw your line. So I'm going to have IJK. Okay, so, and that's going to give me my I into the bracket of k, and then minus j into, minus j will cancel the second column, so this will go here and this will go here, which is 1 minus minus 3, and that is plus 3. And then finally you have your k. So for our k, the last column will go, and so we'll have positive 6. Sorry, we'll first of all take minus 1, which is 1 times minus 1 is minus 1. Then we'll now have minus 6, and that is going to give us minus I minus, minus 4j, and then we now have minus 7k as our solution. Okay, so for the last example, what are we going to do? So we'll first of all take the cross product in the big bracket, and then before we now take it with this dot product. And so our cross product is simply going to be ijk, and then what's the component of the second, which is why I brought in that example. You can see j is missing there. So that means the component of j, or the coefficient of j, is 0, and then you have 1. Please take note of what I just said now. And so let's go to our this thing. So I will have 1 times sorry, minus 3 times this times 1, which is minus 3, then minus 0. And then j, we will have, of course, 1 times 1 is 1, minus 4. And for k, we will have, your column is, this last column will go, so we have 0 minus 12, and that will be plus 12. And so your final product for the cross one is minus 3i, and then we have, this is minus 3 times minus j will be plus 3j, and then we'll now have plus 12k. Okay, so finally, then we will now have to take the cross product with the first vector given. And so all we need to do is to bring out the components there. The component here is 2 comma 1. You can see k is missing in this vector, and just like we did here, we will call it 0. Okay, so you take the dot of this with this other one, and that is minus 3, 3, and 12. Okay, so in now bringing out this dot product, minus 2, sorry, 2 times minus 3 will give us minus 6, then plus 1 times 3 will give us 3, plus 0 times 12 will give us 0. So our final answer for this is actually negative 3. And so you can see we took the cross product first before taking it with the dot product. And of course, like I said earlier, the dot product is a scalar product, so it's going to give you a number, and that's why we have minus 3. This is where we end it for this video. Kindly subscribe to our YouTube channel and do share our videos. We will see you in our next video. Bye.